Welcome to another Programming Exam Solution tutorial for the AQA 2017 Predator Prey exam. It's the Paper 1 exam, it's the A-level exam, not the AS Flower Simulator. I've been asked to do these mini walkthroughs, so that's what I'm going to do. And for this particular tutorial, we're going to look at what I'm calling the simulation cycle. Effectively, what happens when we advance one time period. I'm of course assuming that you've got some vague knowledge of the system. So let's have a look at the class diagram, and we can see that most of the processing happens in simulation. The main procedure, just handling the starting of the program and a few menus, all of the processing happens here. Specifically, advanced time period, and handled within the classes, the subclasses. Sorry, no, it's not subclass. That's wrong. Handling within the classes of Fox and Warren are advanced generation. Advanced generation. Just be aware, fox is a type of animal, that's got advanced generation. Rabbit is a type of animal, it doesn't have that. It's held within Warren, which is a class on its own. I said subclass, I shouldn't have done. Of course, what I should have said was that simulation is composed of location. Location is composed of Fox and Warren. Fox is a type of animal, Warren's a class on its own. So let's move on and look at what we're going to look at today. I'm going to go from the principle that everything has been created, and we're going to look at what gets handled at simulation level, what's handled in the subclasses. Before we look at the code, let's have a quick run through so everyone's clear about what we're handling. Oops. Let's just start it with the default settings. And I said before, please make sure you have tested this code and played around with using this program so much, particularly setting up custom settings with variability equal to 0, and particularly you know what's going to be handled, because chances are you'll get asked questions about that. No one knows, but you know, they've put these options in for a reason. So let's hide the detail. What we can see is Warrens now have a different number of rabbits in. If I show the detail, and we're going to do another time period, you can see that what happens. We know how many rabbits have been eaten by foxes, and it's different foxes. So in other words, in this case, for this Warren at 1-1, 1, 2, 3, 4, 5 different foxes have been assessed to see if they have eaten any rabbits. Okay, let's have a look. 1, 2, 3, 4, 5. Every single fox gets assessed to see if it could have eaten any rabbits from that Warren. Then you can see in show detail that we've got rabbits being killed by the factors, rabbits dying of old age, and how many rabbits have been born. Let's go through the Warrens. Same again, same again. So this is literally looping through every single Warren in the landscape. Then, at the end of that process, we now have a list where each fox is being assessed. So we're looping through each fox, and the details about that fox is being produced. If we really wanted to, we could have a look to check that this 15 for fox at, I've lost it, 210 corresponds to the number of rabbits being eaten by 210 from each of these Warrens, and it should all add up. 210, 15, so it shouldn't have eaten any others. As we look at this process, we will also be just double checking everyone knows the rules by which what means that a fox can actually eat a rabbit in a Warren. And we display the grid again. So over the next, it's going to be realistically about 8 minutes. I will effectively take us through the code so that we can see exactly what happens. just going to pause to get the code set up so that we're in the right situation. Okay, I've whacked a breakpoint into the code and I've executed the code so that we can see exactly what happens. Crucially, when we advance the time period, unsurprisingly, the simulation will call advanced time period. So we have been through and created the landscape. We've already seen this once. If I scroll back up, you can see that. And we've actually decided to run simulation, chosen one. That's the 0th time period, which displays the landscape originally. And we've just hit select option 1. So everything we've just looked at was either handled by the submain or the instantiation method, the subnew if you're in VB, of the simulation class. So let's hide that. We don't care about that too much. The structure of this is pretty simple. Okay, we've got 2 for loops, one here and one here. And one here. The first for loop handles all of the warrens. The second for loop handles all of the foxes. Both of them step through every location in the landscape. Not sure what this looks like in some of the other programming languages, but effectively asks the question. It says, if the warren property within the landscape element isn't nothing, if not landscape.id is nothing, then there must be a warren there, so let's actually do the rest of the code, perform effectively an advanced time period on that particular warren. So it's going through and it's advancing the time period on each location within the landscape. Then it's a quick check. If we've got show detail, then we'll produce the inspect. That's the actual output that we saw when we stepped through the code with show detail a moment ago. After that, okay, we then run these elements, and then we run the inspect again, so we can see what it was like at the start, what it was like at the end. Let's not worry about that for the moment. This is part of simulation. You can see that because it's not being referred to as a method within the class. Go to definition. Hopefully you can guess what foxes eat rabbits in warren does. And this runs through and actually handles each of the foxes. Okay, so it steps through every single element in the landscape, and it says if it's a fox, then let's work out how big the distance is between that fox and warren. And based on these rules, if it's within 3.5 squares, then the fox eats 20% of the warren. If it's within 7 squares, then it will eat 10%, and they're mutually exclusive. Otherwise, the fox is too far away, it can't eat the warren. I would definitely have a little play about changing that. Maybe there's another rule. Maybe if it's within 5 squares, it gets to eat 2%. Who knows what it is? That would be a really easy sort of 2 or 3 mark for them to throw in. Distance between. I won't go to it, but that could be a section C question. It just uses Pythagoras. Definitely have a look at it. It's effectively a little Pythagoras calculation, which of course works for a straight line as well, because that formula does. We then do a bit of rounding, and I've lost. There's a bit of rounding because really you don't want half a rabbit being eaten. We're assuming that they will only eat whole rabbits, and of course this is a percentage, and we need to actually apply that to a particular warren. So if there's 100 rabbits in the warren, I know there can't be, it can only be 90%, but it's 10%, then that should be 10. Now then, so far, other than just checking if the class is, if the object is present in that location, everything's been pretty much handled within the simulation class. Sorry, apart from just getting how many rabbits are in a warren. Really ought to be comfortable about that notation. So this particular element of the landscape, the warren object that's been instantiated at there, and getRabbitCount is a method that returns how many rabbits are in the warren. Slightly more process orientated is this particular element, that warren, eat rabbits. Let's go to that, go to definition. Boom. We're now in the warren class. There's a method, a function, called eatRabbits. Okay. It returns that how many rabbits are going to be eaten. Well, you might be thinking, why on earth do I need that? You know, I can just take, if I'm just taking 10%, why do I need a separate method? I've got the rabbit count. But why do I need to process? Because those warrens are made up of an array of individual rabbits. Each rabbit is an individual, not just a number. It has its own properties. So therefore, when the fox eats a rabbit, it's not just reducing the number of rabbits in that warren. We are actually going to remove individual rabbits from that warren. So let's have a little look at this code. This is going to take more than 8 minutes. Okay, so as long as our death count is less than the number of rabbits to eat, i.e. we're going to keep going, we've already worked out how many rabbits need to be eaten. That's easy. So let's say it was 99 rabbits, 10%, it's roughly 10. Okay, by the time we've rounded it up. And we're going to remove 10 rabbits. Effectively, what it's doing now is picking a random rabbit from the warren. If that rabbit number actually contains a rabbit, because it's possible that this rabbit number will be, let's say I only had 50 rabbits in the warren, so that's numbers 0 through to 49. If this produces 60, then that would be a problem. In fact, that should be handled by rabbit count. Sorry. If this rabbit number produces 37 and number 37 has already been eaten, then the fox can't eat the same rabbit twice. So it will ignore that and it will move on and try again until it gets a rabbit number of a rabbit that's not been eaten. So we have, let's say we're going to eat 10 rabbits. There's 10 rabbits with 10 different rabbit numbers that will be eaten. And effectively all it does is make that rabbit number equal nothing, and it increases death count so that we can handle this loop, so the number of rabbits that get eaten equals the number of rabbits that need to be eaten. Compress rabbit list. At the end, I'll just do this really quickly. At the end of each session where rabbits get killed, all of the rabbits get moved down to the bottom indices of that array. So let's say we had 10 rabbits previously in the array, and it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've killed 3 of them, and they were 1, 5, and 7. Rather than leaving 1, 5, and 7 blank, compress rabbits simply make sure it's now 1, 2, 3, 4, 5, 6, 7. Step your way through that, make sure you understand how compress rabbit works. And we now have finished this, and it returns the number. Let me just zoom out again. Foxy we're here, okay, and we actually form the rabbits to eat. We've basically passed the number in and passed the number out again, but it's purely so that we can give food to the fox. Okay. As well as the warren having to decrease the number of rabbits, the fox needs to make note of how many rabbits it's eaten, because in terms of aging, in terms of its life expectancy, the amount of food consumed has an impact. It's a fairly boring function, because all it's doing is basically accumulating so that we know how many food units have been consumed this period. It's a property. So this is effectively a setter, but it's like an accumulative setter held in the fox class. And don't forget, this is unique for each fox that's been instantiated within the landscape. I think I'm going to split this up into warrens and foxes, but anyway, let's keep going, see how long it takes. We've now handled the first bit of the for loop that's working out the warrens. Okay, so we've talked about foxes eating rabbits. The other big thing in the circle of life, as well as eating, is procreation. I hope you've all had the discussion with your parents, because rabbits reproduce. And if we have too many rabbits, more as in 99, then we need to create a new warren. Okay. It's handled by this getter, which points to a property. Let's go to it, so it takes a second. Which points to a property, and effectively, if our rabbit count is equal to the maximum number of rabbits, then effectively that warren will need to swap. What we do is have it so that we can't keep that warren, once it's spread, can't keep spreading. This is a major flaw in the simulation. It's something that I've addressed in another video. But so we have got a little setup here for the already spread, but also this returns a boolean, and it returns true if it needs to create a new warren. The actual process of creating a new warren is not handled within warren, but it's handled within simulation, and it creates a new warren. And the sort of standard way in which this program seems to work is it creates a couple of random values and it tries to place them. If there's already a warren there, it will create another couple of sets of values, and it will keep going till it finds a space where there isn't a warren. Notice that's a little bit similar to when the fox is eating rabbits from the array of warren. Similar sort of way of working. If we are going to place a new warren, well, that's easy. We just instantiate a new warren. We obviously do it at the location of warren, but just in case you're not familiar with the instantiation method of warren, let's have a quick look at it. Okay, not quite sure why that didn't zoom down. Warren, there we go. It's an overloaded function. There's two different versions of it, but it's this one with just the variability that's going to get passed. And as we can see, it creates a new warren with a random number of rabbits, and then it creates those rabbits by instantiating new rabbits and placing them at a particular position in the array. I strongly recommend you step through that and inspect the array so you know what's going on there. So we've created a new warren which creates lots of new rabbits and placed them in the warren. Let's go back. Crucially, that has happened before we actually advance the generation of the warren where the rabbits reproduce. So this is being done basically at the start of the time period. So at the start of the time period, foxes kind of eat a load of rabbits, and we decide if we need to create a new warren and create a new warren, and then at that point the warren advances a generation. So this is the warren advanced generation, not the fox advanced generation. So periods run simply sets a or increments a property up here. That's just to keep tabs. It's pretty much purely for display. Then we have a bit of a sad time for the rabbits. As long as we've got some rabbits in the warren, we kill a few off. If we have a look, effectively we have a little check, and if that rabbit has already been assessed to be killed by another factor, that was done somewhere else. But if that returns a boolean, then it kills the rabbit and increases the death count. We will worry about how that happens another time. Then we age rabbits. Oh, I've lost it. There we go. Definition. Here, all of the rabbits are increased in age by a value. So you can see here that it says calculate new age. Again, this happens in the rabbits class. Let's not worry about that for the moment. We'll look at that later. Crucially, some of the rabbits, if they're older than their lifespan, will have died. If that's true, then check if dead will have been set to true. So that is just a boolean within the rabbit class. If the rabbit's dead, check if dead will be true. If that's true, that rabbit is then obliterated. Death count goes up. Sorry if you're a rabbit lover. Again, nice thing about OOP, we've sorted that out somewhere else. We've sorted the aging out somewhere else. We're just going to magically age them. Just trust that the class does its job. So we've checked how many rabbits have been killed by the factors. We've checked if any rabbits have aged, and if they have aged beyond their lifespan, they've died. And then finally, we've killed them off, and now we're going to let them reproduce. As long as we've got some rabbits left, and as long as we haven't got a full warren, hello, sorry, and we haven't got a full warren, and as long as the warren contains males, again, let's not worry too much about that, but hopefully you can guess what that does. It iterates through the array. Where is it? Go to definition. It iterates through here, and as long as there is one that isn't a female, then it must be a male. That's a boolean. So as long as it contains males, it will run mates rabbits. So it is pretty careful how it reproduces. Foxes reproduce by magic, apparently, according to this program. But rabbits, and again, I really hope you've had that conversation with your parents. Rabbits, there has to be a daddy rabbit and a mummy rabbit to have a baby rabbit. This is so specific, I suggest you make sure you understand this really well. I would, in terms of my students, this was in the mock. Because this is a nice little bit of code. Effectively, we're going to loop through, pick a rabbit. If it's male, we're going to try and mate it with another rabbit that has to be a female rabbit. And only if we can do that. And there's a reproduction rate, which is a property of rabbit. If the combined reproduction rate is there, then we will create a new rabbit, and it's placed in a place on the array which is effectively the next empty space, because that was rabbit count. We know how many babies there are, so therefore it gets placed in there, and then we just keep tabs of how many babies have been created. Step through that. I'm not going to now. Make sure you understand it, but make sure you understand that effectively we're looping through the whole array, and then for each female rabbit we're looping through to find a male rabbit, and as long as their reproductive rate is above a certain value, they will have a baby. The last little thing is that should all the rabbits be dead in the warren, then it just produces a little message saying all the rabbits are dead. Obviously, show detail has to be applied. I've ignored show detail, by the way. I'm assuming that you know that you can either advance time period without detail or with detail, and show detail base just says there's going to be an output. I strongly suggest that you understand that. I'm quite sure that there will be something where you create a new function that does something to the warren or does something to the fox, and crucially you have to create a little thing where if show detail is true, then it will do a console.write line for a particular value. So kill the rabbits by other factors, kill the rabbits by old age, let the rabbits mate, check to see if the rabbits are all dead, and if they're not, we've just advanced a generation. Let's go back. We're almost halfway through this. The foxes are a bit simpler, by the way. So we've now done this, and if we've got show detail on, then we will reproduce the inspect and output the various things that are shown there. And if you want, okay, it says how many periods you run, how many rabbits you've got, and it does that for each warren. And again, if we've got warren has died out, and that's a boolean that's set if the rabbit count equals 0, then we actually remove that warren object from the location, or set it to nothing, which is the same as. Right, you're going to need to look over that yourselves, but hopefully that's a reasonable explanation. Let's keep going. I'll put some time flags in so that people can jump straight to the fox or straight to the warren. We've now been through the entire array of landscape, and we've looked at every single warren that happens to be there. We now do exactly the same thing for the foxes. Every single element, for every time we hit an element that has got a fox, i.e. not fox equals nothing, then if it's show detail, we say we're at fox such and such. Otherwise, we advance the generation of foxes. Curiously, we advance the generation of foxes before everything else, whereas the rabbits we do it kind of at the end. So I'll let you think about the code to say why that's true. Let's go straight to it. So we've got, oh, sorry, I've just scooted out of there, sorry. So if I go, get rid of that, and I go to, sorry, fox advanced generation, go to definition. This is where everything happens. If they don't eat, if they haven't consumed any food, then they die. If they're killed by other factors, they die. And that's done by setting is alive to false. If they've had some food and they've not been killed by other factors, we need to see had they had some food but not enough, in which case this says calculate new age. It really means increment age. That's really what it means. Okay, so they age here, but crucially they're also going to age here. So let's go to definition. As you can see, all this is doing is incrementing the age and checking if their age is greater than the lifespan. If their age is greater than the lifespan, then is alive is set to false. So they get aged for not having enough food. They also get aged anyway, just because foxes age. At the last little thing, it double checks, oh, has the fox actually died of old age? So it's a much simpler process. Check how much food they've had. If it's nothing, kill them. If it's something but not enough, age them. If they've had enough food, then basically it scoots through here doing nothing, as long as they haven't been killed by another factor, which is just a random process. So let's go back up to our landscape. Landscape advanced generation. Right, if the fox is dead, again, that element of the landscape, fox, make equal nothing. If the fox isn't dead, then at this stage it decides, will it reproduce this period? Simple, random chance of whether it's going to reproduce. Okay. That's hard-coded as a constant. So effectively there's a quarter chance of it reproducing. Yes. So as long as it's less than that, then it will reproduce. Otherwise, false. I was just double checking it wasn't 3/4 chance, but it's a 1/4 chance. So if the fox has reproduced, then we increase the fox count by 1. You might be thinking, well, we can't increase the fox count by 1. We've got to somehow put the foxes in. The reason why we don't put the foxes in at this stage is what we don't want to do is to be carrying iterating through and start to also apply this code to the foxes that have just been reproduced. They've just been produced. Okay? So what we do is we're sort of saving up this number, and after we've been through the whole grid, then we'll start placing foxes into the grid. And at that stage, if show detail, we have an inspection where we just show the various details about the fox. Again, just says whether they've had enough food or not. And where are we? The last little thing, we have to reset the amount of food consumed, because we have, even though it looks like the fox hasn't eaten, if you remember, when we executed the code about the warren, for each warren it looks at each fox and decides how many rabbits it's eaten. So actually the fox eating code happens in the part of the simulation that actually is looking at warrens. But we need to make sure that all the fox's food gets reset for the new time period. Then after this loop, we check. If we've got some foxes, then for each new fox, we've got to create a new fox. That's in simulation, but all it's really doing is calling some code, exactly the same as create new warren, exactly the same. Pick a random location, make sure there's not a fox already there. If there isn't a fox there, bang, run the instantiation method of the fox class. So make sure you understand, why can't we create new foxes in this bit of the code? Because then, as it iterates through, if this fox was created further along the array, it would run this code and advance the generation, and magically a brand new baby fox will be aged 1 year before it even starts. Crucially, that fox didn't exist, so it wouldn't have had any food, so it would die. So in fact, all baby foxes will be killed in their first year, which would be very sad. Last little thing, we draw the landscape again, so we redraw the landscape. I don't really want to step through that, but I'll just very, very quickly show it you. Definition, and this should be absolutely bread and butter to you. Completely understand. All we're really doing is just concatenating a long right line to the screen, and that's comprised of some sort of literal elements to make the grid look nice, and also the number of rabbits in the warren, and wherever there's a fox, put an F. That's enough of that. You can step through that and see it magically appear. So we've looked at advanced time period. We've looked at how the warrens get handled. We've looked at how the foxes eat the warrens. We've looked at what foxes eat the rabbits in the warrens. Sorry. We've looked at what happens when we create a new warren when it's full. And we've looked at how rabbits advance a generation from within the warren. And all the different sad ways in which they can die. We've done exactly the same with the foxes, and the slight little quirk about the fox reproduction. I don't think you're going to be asked to apply the mummy and daddy fox algorithm like there's a mummy and daddy rabbit algorithm. I suppose you could, but I think when you start to look at it, you realise that you change a lot. So at the moment, foxes reproduce by magic, whereas rabbits reproduce by the sort of more biologically correct way. We've now been through one entire time step period, and if we go back to simulation and we go back to what actually happens, time period, you should be able to see that we will get through this do loop, be dumped back into this menu. This is where we started. If we pick show time period equals false, time period advances, and we call that at the end of it, we'd get dumped here. You can see there's absolutely nothing else outside of the menu option selection, and as long as we've got some foxes or some warrens and we haven't hit 5, we get dumped back up into the top of this do loop. So this advanced time period was all called from this menu option, either hitting 1 or 2. Right, that's nearly 40 minutes, crikey. I will put some timestamps on the comments so that you can jump to the relevant bits. But if you've somehow managed to stay conscious through that video, well done. I hope you found it useful. Hopefully my garbled explanation makes sense. You've got to step through it yourself. Just step through the code. Make sure you understand exactly how each bit works. If you're in VB, it's just that. Just keep stepping through, step through. Make sure you understand what actually happens, what actually outputs. You can inspect at any stage the entire. So at this element, we can see there's nothing there. If we went through to an element which had landscape, you would see. In fact, can we look at the entire landscape grid? We'll look at just that element for it. Then you can see exactly what's going on. You need to see what data is flying about. Really hope you found that useful. And yeah, let me know in your comments if you've spotted any mistakes I've made. And again, ask if there's stuff you want. I'm more than happy to create things that people have asked for.